Solving quadratic equations. Thus far, we've had two main ways of solving quadratic equations. One, which was factoring, only works for things that can be factored, and you have to set the equation equal to 0, factor, and solve. The other was the use of the square root property, which only works when an isolated squared expression equals a constant number, and you take the square root of both sides and solve. So in the case above, we could use either of the two methods to solve this. And so what we're going to do is we're going to look at some previous methods we've used to solve before we move into completing the square. And so for this case, if I use factoring, well, in case of factoring, I have to take what I have, and then I have to move everything to one side or do the additive inverses to get my equation equal to 0. And then I would factor this. This is the difference of two perfect squares, which gives me x times x and positive 8 and negative 8. Then setting each of my factors equal to 0 using the zero product property. I would then solve for the x value, getting x is equal to positive 8 and x is equal to negative 8. So using factoring, I set it equal to 0, I factored and solved. On the other side, if I want to use the square root property, I would start with x squared is equal to 64. I would recognize that I have an isolated squared expression, which is on my left, and it's equals to a constant, which is 64, which is on my right. The next thing I would do is take the square root of both sides. And so I should end up with x is equal to, and remember, we get the positive and negative square root when we take the square root of a squared term. So I get x is equal to plus or minus, well, the square root of 64 is just 8. So I get plus or minus 8. And notice, in both ways, I get two answers, negative 8 and positive 8. When solving this type of equation, I could still use, I'm still allowed to use factoring and the square root property. And so in this case, I would take x minus 2 squared equals 25, or equal to 25. I would multiply out what's on the left side, remembering that this is a binomial times a binomial. And so I get x squared minus 4x plus 4. I have 25. Again, since I'm factoring, I must make it equal to 0, set it equal to 0 by moving everything to one side. And so I get x squared minus 4x minus 21 is equal to 0. When I factor, I end up with x minus 7 and x plus 3, because I'm looking for two things that multiply to give me negative 21, that add to give me negative 4. And as I do this, I get x equal negative, x minus 7 equals 0, x plus 3 equals 0 by setting my factors equal to 0. And by solving for x, I get x equals to negative 3. And I get x equal to positive 4. Positive 7. So that's using the factoring method. It's a little bit longer in this case. And if I was to choose a method, I probably would choose the square root property method. And so starting again, I would end up with x minus 2 squared is equal to 25. I take the square root of both sides. And so I end up with x minus 2 is equal to plus or minus the square root of 25, which gives me x minus 2 is equal to plus or minus 5. And again, I'm getting two answers for this, so I'm going to end up by adding 2 to both sides. And I end up with x is equal to positive 2 plus 5, or positive 2 minus 5. And that would give me my positive 7 and my minus 3. So again, I get the same answer by using two different methods. In this next case, I could either try to factor or I could try to use the square root property. Well, just by looking at it, I recognize that I don't have a squared term, a squared expression on one side equal to a constant. So that's really, the square root property is not really what I want to use. And if I actually try to factor this, I have to set it equal to 0 first. So X squared minus 8x plus 16 equals 12. I subtract 12 from both sides. That doesn't cancel, excuse me. Subtract 12 from both sides, and that gives me x squared minus 8x plus 4, equals 0. Now, if I look for two things that multiply to give me 4 that add to give me 8, those two, there aren't any two integers that actually works for. So I actually have to figure out, what do I do now? How could I actually get an answer for this when I can't factor what I get, and it's not the square root, it's not an isolated squared expression? And so what I need to do is I need to think about what I saw when I started. And so what we're going to do is we're going to use a new method, which is called completing the square. And completing the square is done by recognizing a perfect square trinomial and using that to our advantage to use the square root property. So in this case, hopefully you can recognize that x squared minus 8x plus 16 is actually a perfect square trinomial. And how would I recognize that? Well, it's really in the form of x squared minus 2 times 4, x squared plus 2 times minus 4 times x plus minus 4 squared. And so really what I'm looking at on this side is x minus 4 times x minus 4. So if you didn't recognize that this was a perfect square trinomial, when you tried to factor only the left side, you would see that you get x minus 4 and x minus 4. And since this is equal to 12, well, really what I end up with is x minus 4 squared equals 12. And now I have basically what I was using before. I have a perfect square, or an isolated squared expression on the left, and it's equal to a constant. I can use the square root property to take the square root of both sides, and I get x minus 4 is equal to plus or minus, you have to get two answers, plus or minus 12. Then I'm going to have x minus 4 is equal to, well, I'm going to simplify the right side to get an exact answer. So I'm going to have plus or minus, the square root of 12 gives me the square root of 4 times the square root of 3. And so I get x minus 4 is equal to plus or minus 2 square root of 3. And then to find what x is, because I'm solving this equation, so I have to isolate the x. I'm going to add 4 to both sides. But I have to remember that the plus or minus 2 is attached to the square root of 3, and therefore it's not a like term with a positive 4. So I get x is equal to positive 4 plus or minus the square root of 2 times the square root of 3. This is the exact answer. I get an exact answer from this because I end up solving this. And as you can recognize, because I end up with two answers, 4 plus the square root of 2, 4 plus 2 times the square root of 3, and 4 minus 2 square root of 3, that allows me to recognize that I don't get integer solutions or even rational solutions, which is what I would have gotten from factoring. Okay? If I was able to factor, if I had the ability to factor, I should have gotten a rational solution, which means solutions that could be fractions. And I don't get that. So what I'm doing right now is I'm just using the square root property to allow me to solve this problem.